Hey guys, welcome back to this tutorial on C++ programming snippet. In the previous tutorial, we demonstrated three features of C++, namely classes, object, and encapsulation. And we did so by creating a component class with two private members, name and val, right? Then, because these variables are private, they're not available on the outside world, we have to create two public member functions, component and info. Now, the component function make public these private member variables. And then the info function make them accessible to the outside world. And then we created object here, and then we call them here. In this way, we demonstrated the usage of classes, object, and encapsulation. The tutorial link is on the description box below for those who haven't watched it yet. And in this tutorial, we're going to continue where we left off. And we're going to attempt to implement another three key features of C++, namely abstraction, inheritance, and polymorphism. So don't go away, stay until the end of this tutorial so that you can grasp some of these important concepts of C++. And if you find this tutorial useful, please give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. And also don't forget to support CMTEQ channel by sharing this tutorial. So without any further ado, let's go ahead and implement an abstract class or abstraction into our existing code here. So what is an abstract class? Well, to answer your question, an abstract class is simply a class that is specifically designed to be used as a base class. So that means there will be other classes in your C++ code that must inherit from that class, which is the base class, the abstract class. So that automatically also implement inheritance. So this means you cannot implement abstraction without inheritance. So we'll be shooting two birds with one stone here. We will implement an abstract class and it will also give us the inheritance features. So to create an abstract class, I'm going to go ahead and copy this normal class or a non-abstract class and make a copy of it. Okay, now an abstract class is a class that must contain at least one virtual function that others must inherit from it. So what I'm going to do is I'm going to modify this function here, make it an abstract class, and then we'll come back and rename this function after. So to do that, I will delete the implementation of this function here and make this function a virtual function by making it equal to 0. Now the code will complain here and it will say, well, you are making it a pure specify equal 0. That's only allowed for virtual functions. Okay, so which means we must just add a keyword here, virtual. And that is going to make the compiler happy. So this now become a pure virtual function. Thus alone here, turn this class into an abstract class because we can now inherit from this virtual function here. So this is now our base class, our abstract class that we can now inherit. It still has private members there, and there is a one public function that makes this private variable available, and we've got our virtual function that we can inherit from. Now we need to go ahead and create a normal class that can inherit from the abstract class. Now another key aspect of an abstract class to remember is that you cannot instantiate it. So which means you cannot make a new instance of it. Let's say if that class, this abstract class, was called test, so you can't say test t equal new, right, and then test. You can't say that. If it's an abstract class, it's going to give you an error because it's an abstract class. You can only create an instance or instantiate a non-abstract class. Now let's go ahead and modify our non-abstract class, also known as a concrete class. This is a base class and this is a concrete class. Now we need to make this program to still make sense to us, right? So our task here is we were writing a C++ program to list a component and its value. So now we've got an abstract class of component. So what will this class be to still make sense for our topic here? So I'm going to change this class to electronics, right? Electronics component. So this class is called electronics component. We leave the component out, just electronics. Now to make this class to inherit from the abstract class, we need to insert or include the keyword public. So to do that, I'm going to go ahead and add the keyword public and inherit from the component class. Now notice that this non-abstract class is still going to return its private members here. So what I'm going to do here is I'm going to add another variable of type string, and I'm going to call it circuit, right? And I'm going to go ahead and change this name as well so that it can match the class name. So electronics. Now you can see the error is gone. We still have to fix here because now we cannot create object using the component class, right? Because the component class does not exist anymore. The class with the name component is not a normal class. It's an abstract class, so we cannot create object with it. So now we can only create object with our electronics class here. Now let's go ahead and first fix the problem here. Now we know that the electronics class here got 3 private variables, so which mean the public function electronics, right, must also include 3 variable or 3 public variables. So I'm going to go ahead and add circuit here. So string circuit, and just like we're making the variable name and val public here, we have to also make the variable string public. Okay, so I'm going to change here and make eCircuit. Then we're going to add a line of code, this, and we're going to say circuit is equal to eCircuit. Right. So now we've made all our variable that were initially private public so that it can be accessible from the outside world. And notice we've got an error here that say no default constructor exists for class component. And that is because we need to inherit the component member function of our abstract class into this class here. So to do that, I'm going to go ahead and call the component member function, and we need to pass the variable that goes into that member functions, and the variable are the integer and the string. Okay, so I'm going to go ahead and pass val and name. Right. So now we are almost done with our implementation of our concrete class here, that is basically inheriting from the abstract class, the base class. So now all we have to do now is to basically create object here so that we can call our concrete class, and hopefully there's not going to be some major error in this program. So let's come to our main function. Since we no longer have a components class that we can create object, let's change that to our now class that we can create object, which is the electronics class. So I'm going to copy there and paste here, right? And here as well. Okay, then we need to change this object here to electronics 1. And we're going to do exactly the same thing here on our second object here. Hopefully this is still going to make sense to us, and we're going to change that to object number 2. And the way we're going to call it is exactly the same way we did here. So it's going to be electronics1.info and electronics2.info, because this function here that is inheriting from the virtual function haven't changed. Okay, now we've got a problem here because this object electronics one, which is inheriting from this electronics class, that got a member function electronics. Okay, that takes 3 arguments and we are only passing 2 here. So we need to fix this. So we have to add another argument, right? So there is a resistor, that's a value. So the third argument should be electronic circuit. So I'm going to go ahead and add an argument here and say circuit. Okay, then we need to make this to make sense to us. Okay, so circuit like that. Okay, now it is happy. There is no more problem here. Let's go ahead and save. Now let's go ahead and give this a try. So we're going to go ahead and run, and we're expecting to print something here. Okay, whoops, there is no output. There is a problem in our code. Now it seems everything looks fine here. We've gone through it line by line, unless we need to override this function here which we are inheriting from the base. So we have to override it, right, so that we can basically change the base usage, right, the base implementation of the function. So let's go ahead and add the override and see if that's going to solve our problem here, and then try again. Whoops, still nothing. Okay, what is going on here? Let's just see line by line again here. Okay, no problem there. Component public member function of the base class, cval, cname. We inheriting there, and here by the component. Oh, okay, there we go. The variables that we are inheriting from the public member function of our base class. The variable here are cname and cval. But now here we basically inheriting val and name, which are private. See, val and name are private, so we cannot access them. We don't have access. That is why when we passing the value, right, the value and the name here, basically we are not able to implement call our info function because this is not working, right? Because we cannot get access to some of the variable. So to fix that, we basically need to change to the public variable cname and cval. There we go. So I'm going to add a c there and a c there. Save it. This time around, hopefully we can get something. Let's go. Here we go. This is a 10 ohm resistor. This is a 15 microfarad capacitor. Now, even though we are passing a circuit here, it's fine. I mean, the class is accepting it based on the function here, but the implementation, we are not using it. It's not a problem. We are passing the variable because we're calling the function, but we're not implementing it here. So to make it print, right, we have to modify here. So we're going to say this is a 10 ohm resistor, right? And I'm going to add another line of code and say it is part of an electronics, right? And then I will pass the variables circuit, right? So that is circuit, like that. Okay, let me go ahead and copy this part here, right, and paste it here as well. Now we are ready to run this again. We are ready to run this again, and hopefully we're going to be printing something more meaningful. So let's go. There we go. This is this is a 10 ohm resistor. It is part of an electronics circuit. There we go. We just need to clear some space there on it is, right? There and here. Something like that. So that is it, guys. This is how you basically implement your abstractions and inheritance. Now this tutorial is getting a bit too long here. I'm going to stop it, right? This is a 15 microfarad capacitor. It is part of an electronics circuit, right? So we've successfully implemented classes, object, encapsulation, abstractions, and inheritance in these electronic component classes here. So we're not going to look at the polymorphism, and hopefully in the next tutorial we're going to add some other key features of C++ and continue to improve these tutorials. So guys, if you found it useful, don't forget to subscribe to CMTEQ channel and give this tutorial a thumbs up. That will be highly appreciated. And also share this tutorial. That is the right way to support CMTEQ channel. Until next time, cheers.